So we'll go ahead and get started. I'm going to try to make this one a bit more efficient today, not cannibalize too much of folks' time. What we've been doing over the last month and a half or so, every Tuesday we try to peel back the onion a bit on some of the more low-level technical features, either in the platform or in our marketplace. And then on Wednesdays, we do a more high-level walkthrough, 101 sort of oriented, how to create a network, how to create and configure an environment, stand up your nodes, instantiate a basic smart contract, and then interact with it in one of two methodologies. For today, we're going to take a look at Chainlink, an Oracle service that we had. We did look at this, I believe, last week, but we had rather low attendance, and it's a fairly useful feature, allowing you to kind of integrate external data feeds into the chain. So I just wanted to revisit that and just hammer home some of those concepts. And then we're also going to take a peek at kind of just the basic methodology for core cloud integrations. We let you weave key management services, backups, log streams, and private networking directly into your Kaleido node. These are all private, autonomously controlled services in your own AWS or Azure account. Quite easy to configure, actually. Just want to make everyone aware and provide any edification on those steps and just the protocols that go into configuring that. So I'm going to share a handful of slides, just do a introduction here, then we'll dive into Chainlink, dive into those cloud integrations, and do any questions or sort of interactive back and forth as it comes up. So let me go into present mode, and we'll go ahead and get started. Okay, so at a very high level, three core tenets that really define Kaleido, built very much for modern business networks, use case industry agnostic. We'll see on a slide coming up here that we have a really diverse mix of customers, spanning capital markets, spanning energy, supply chain, governments, etc. The platform itself at the blockchain layer, very radically simple in a good way without sacrificing any of the core enterprise requirements or core configurations. At a smart contract and at a programming layer, also very simple with clean REST APIs behind every admin action, every service, every smart contract interaction. And then the third, very much built for the enterprise as well. So high availability, disaster recovery, auto scaling, encryption, key cloud integrations available, ISO 27000 compliance, all of the core checkboxes that would need to get ticked off by an administrator or a risk compliance officer. What we've done with Kaleido is we've really tried to flatten the curve for adoption of this new technology, making it very easy to wrap your head around just the core chain layer, whether it's choosing between different node clients, Geth, Quorum, Hyperledger, Besu, and accompanying algorithms, and sort of taking that friction, that resistance away, so that you can really progress to pilots and ultimately to production, where a lot of problems do rear their heads. As you start decentralizing your networks, you have to start asking questions about member onboarding, permissioning, governance. And then as your network sort of dynamically expands, you need to have the ability to onboard different regions around the world, and you need to be able to cope with the enormous amounts of throughput and a growing number of nodes inside of your network. So we've really tried to flatten the curve from POC to pilot all the way into production. One thing that we've definitely noticed working with those diverse customers that I mentioned, we see the blockchain piece as a critical piece. The nodes, the algorithms, the smart contracts, that's the beating heart, that's the trust anchor, that's that distributed ledger that everyone's going to maintain collectively. But it's a rather small piece of the overall stack. There's a lot of off-chain components that need to be integrated. And then there's a lot of different, sort of solutions and pieces of functionality in the broader stack, such as oracles, that need to be addressed. So super quickly, kind of just a very high level, view of how we see the stack moving from the bottom up. You have these critical questions you need to answer about data. How do you integrate your private off-chain data? How do you then reference it on the blockchain? at the actual blockchain layer and the transaction layer. How do we do private transactions? How do we leverage privacy groups and transaction managers with Besu and Quorum respectively? And then how do we reliably consume events coming off the blockchain? This is actually a really critical one. Rather than having to poll via WebSockets, on your nodes to, receive transaction receipts or to actually query the chain layer to see pertinent updates and state information, you want a mechanism, you want a pipe that's just going to reliably deliver you anything that matters to your use case, to your business, so that you can just automate your back office processes and your own logic. Scooting a bit higher, this is where we start thinking about oracles, where we need sort of this democratic collective data feed. We don't want a single player unilaterally injecting, ostensible sources of truth into the blockchain. We want to be able to leverage decentralization and a trusted endpoint, a trusted API for everyone to, use for their smart contract updates. And then at the top layer, potentially the most interesting layer, we're actually building out a dApp or an application. This is where we get into tokens, fungible, non-fungible. We start getting into the ability to exchange those tokens, to burn them, to pause them, to swap them for certain levels of token transactions. This is where zero knowledge proofs can become really important. Having the ability to do complete darkroom trading with full confidentiality, anonymity, privacy. And then my favorite piece inside of Kaleido is our API gateway. And this is where we've just made it really, really incredibly simple to basically interact with smart contracts and to have a collective, transparent source of truth for smart contract management, removing the need for Web3 client libraries, SDKs, and some of the trickier low-level Ethereum APIs. Kind of touched on a lot of this, but just worth reiterating, everything we're going to look at inside of the demo today and on Wednesdays with just the construction of a network and a blockchain environment. There is an API behind everything, at the chain layer, at the admin layer, at the smart contract layer, at the services layer. All of those sort of pieces in the stack that I just touched on, there is a marketplace pluggable, embeddable service that addresses all of those requirements. Those either exist as first-class citizens inside of the Kaleido stack, or they exist inside of our marketplace, where again, you can automate their deployment, or you can use the console to just drag and drop and instantiate those services. So with Kaleido, your true focus is not on the blockchain layer. It's not even on the service layer. It's identifying the componentry that you need, having some basic, RESTful web development skills, but focusing the core, majority of your efforts on the smart contract logic, and more importantly, on a wonderful user experience for your end users. So we've made all of those pieces really easy so that you can actually focus on that UI, that UX, where people can really consume the value and may not even have to know that a blockchain actually exists, behind the scenes on the server side here. High-level touch points on Kaleido, super, super simple to create instant networks with any configuration you want. Great services around tokenization, cross-cloud borderless deployment orchestrations. So you can run on AWS, you can run on Azure, you can have nodes on both of those clouds inside of a blockchain, tunneling, peering, communicating with each other. Very easy to decentralize your network and embed permissioning and governance. We have this fantastic marketplace. I always call it a rich ecosystem. My analogy is our marketplace is the grocery store where you have access to all of the ingredients you need to build the meal. And then inside that marketplace, some really cool cutting edge, bleeding edge innovations like zero knowledge proofs, like tethering to the mainnet, like smart contract management. Just to touch on enterprise grade, these are all things that are available out of the box on Kaleido. ISO certification, really flexible techniques on key management, delegated signing, HA, DR, business continuity with backups, all available. And then some native cloud integrations, enterprise integrations, a couple of which we'll look at today. Quick snapshot of a handful of the customers and clients running on Kaleido. You can see a really, really diverse, eclectic mix, spanning finance, spanning energy majors, spanning brands and retailers. Super quickly, just to give you some bullet points on what some of these folks are doing. We see Covantis and Comgo involved in trade finance. We see the World Wildlife Foundation using token curated registries, Tato doing supply chain, Green Fence involved with movie studios and brands and retailers using non-fungible tokens, on and on and on. So this is reflective of how flexible and how applicable the Kaleido stack is to any use case, any industry. With that notion of flattening the curve and trying to help you get from POC to pilot to production, we have a ton of really flexible pricing options and pricing packages, with credits, with time boxed packages, with sort of the fully fledged access to all of the resources, so you can build out a true facsimile of what you would run in production, and then really simple graduated pay-as-you-go tiers with a free starter plan, all the way up to our enterprise tier with all the bells and whistles around open ID integrations and flexible encryption, delegated signing, etc. So lastly, why Kaleido? A few final touch points, but objectively rated #1 blockchain as a service on the market, all of the industry first innovations in the marketplace, HADR ISO compliant, really worth honing in on that. And then a very unique orchestration model, whether it's on-prem or whether it's cross-cloud in AWS or in Azure. So there's me flying through the slides. I see a couple questions. Let me grab those. Not at the moment. One of the questions is this running on GCP as well. Out of the box, we have AWS and Azure. We do have support for Kaleido private stack though, where you can essentially run a private deployment of software, tunnel back to a cloud hosted Kaleido orchestration. We're going to be sharing all of these slides and all of these recordings, and thanks for these topics, Musi. We can touch on identity constructs, and we'll show another example of an actual fully fledged turnkey application as well. So let me close this out and we'll dive into Chainlink now. So Chainlink is one of the 2 Oracle services that exists on the Kaleido platform. We also have Rhombus, which is a group at Consensus, and that's a more bespoke orchestration where you actually work directly with their team to customize an API and customize a data feed. They're going to actually deploy a Lightning smart contract onto your network, which will interface with your core Solidity smart contract, your basic Ethereum smart contract. And that's quite similar to how Chainlink works. You have 2 ancillary smart contracts when you're thinking about Chainlink. You have an Oracle smart contract, which is going to run a job for you. And a job is just a JSON definition of what API to call, what URL to go to, and what data to bring back. And then you have a link smart contract, just a basic token smart contract that's going to hold a balance of link tokens, serving as utilities, allowing you to execute these instructions. These 6 steps, I'll make this a bit bigger for folks, but this should be pretty easy to wrap your head around. The first thing you do using the Chainlink service is you create that JSON definition, you create that job, and your client smart contract is going to be interfaced or linked with an Oracle smart contract. So you're going to specify the job that you want this smart contract to execute, namely that API, that endpoint that you want it to go to, and the payload that you want it to return. This is going to be passed on, create the event. Your Chainlink node is going to actually go out and call that API and return that data. It's going to then proxy that payload back to your Oracle smart contract, which will ultimately deliver that back to your client smart contract. So a very synergistic flow here. The relationships are pretty straightforward. This has your balance that allows you to have link and allow you to execute these instructions. This guy is ultimately going to hold the response. It's going to proxy it back to your client smart contract that you can then use to automate whatever business logic you have, whether it's the LIBOR rate, whether it's a stock market, foreign exchange rate, etc. So that's high level Chainlink 101 there. What I've done, we're gonna skip sort of the creation of a network, creation of an environment. What I did was I created a Tech Tuesday misspelled consortium here. But in any event, this is the business network, and then inside of it, I've created a single environment, a dev test stage environment here, running Quorum and running IBFT. And I've spun up 3 nodes. We always want, at least 4 nodes if we're running Istanbul BFT for proper Byzantine fault tolerance. And then I've just deployed a single Chainlink service. All of the services in Kaleido, they are automatable via our API, or as I mentioned, right inside of the console, you can just use the services dropdown and you can grab and choose any of the services that you need, whether it's the Tether service, whether it's our private document stores, whether it's IPFS, HD wallets, token utilities, or in our circumstance, Chainlink here. So I did that. That container takes about 30 seconds to come up. And then what we're going to do here is we're going to actually leverage a public GitHub repository that we have on Kaleido, showing you how to do kind of a full end-to-end deployment of the Chainlink library, of a chain-linked smart contract with a job specification as well. And this is going to use Truffle as the driver to compile and then run some unit tests against your smart contracts. So hopping back in, we'll go into the Chainlink user interface here. So we see that we have 5 interesting endpoints here. We have the API endpoint for the actual service that we're running, the actual Chainlink node. Then we have a username password for us to get into the administrative interface. And perhaps most importantly, though, we have our token smart contract address, our link address, and then we have our Oracle address, which is going to receive that data back from the Chainlink node and ultimately proxy that payload back to our Ethereum smart contract. This is the account that we'll be using to sign. So we're going to need to fund this guy with some Ether, with some Chainlink tokens. These are worth whatever you want them to be worth in the context of a private network. So we basically have an Ether pool, a Chainlink pool that you can use to disseminate those tokens and to fund any accounts that need those assets. So the first thing we'll do is we'll go ahead and fund this guy with some Ether and with some Link. So we'll give them 1,000 of each. And then we'll go ahead and log into the Chainlink admin dashboard and start configuring our job. So we've given them some Ether, and now we want to give them some Link tokens as well. We'll give them 1,000 of those. And I'll get to the questions that are coming in the chat and in the Q&A. I'll try to do 5 to 10 minutes of demonstration uninterrupted, and then we can do the sporadic interruptions here. Okay, so we funded that guy with each of the 2 tokens. Now we want to actually access this interface using the username and using the password. So we'll go ahead and open this up. First, we want to copy the username, and then copy that password. And we'll have our admin dashboard, which won't be very interesting at the moment because we don't have any jobs created. But we do have some Ether and we do have some Link tokens here that we can see specified in way. Okay, so the first thing we want to do is we want to create our job specification. And these are not scary, these are not complicated. This is a lightweight JSON definition, just telling the Chainlink node where to go and what to return. So inside of our Chainlink repository, we have a sample JSON payload, a sample job specification. This is going to actually return the Bitcoin price, not the Ethereum price, but you can see that you're just basically telling it what type of call to make and what API endpoint to go to, and then how to parse or how to deal with the data that comes back here. So we'll copy this blob of JSON here. We'll go into our Chainlink admin dashboard, and we will create a new job here. And what we're ultimately concerned with is we're ultimately concerned with the job ID. We want to tell the Chainlink node specifically what the instructions are that we want it to create. So we've created this job and we see the ID here, 12E2D, blah, blah, blah. And that's ultimately an environment variable that we're going to need to export inside of our Truffle environment, inside of our program, so that can be passed on to the Chainlink node, and that payload can be ultimately returned to that Oracle smart contract. Okay, so we're concerned with this, and ultimately we're concerned with a secure API RPC endpoint so that we can actually speak to Kaleido. So first thing I'll do, and I'm going to have to hop back and forth between my terminal here. So get your eyes ready to see some moving screens. But the first thing we want to do inside of our truffle environment here is we want to export some key environment variables. So we definitely want the job ID, that's a key one, but we also need our node URL, our endpoint for Kaleido, and we need these two addresses, our token smart contract, and then our Oracle address, which again, I'll keep reiterating, this is the guy that's going to receive the payload from the Chainlink node and ultimately proxy it back to our, it's called ethprice.sol in this scenario, but whatever your smart contract is. So the first thing we want to do is we want to export a job ID variable. So again, this guy right here. So we'll copy that. And then inside of our clipboard here, inside of our terminal, we're going to export that. Okay. And then we're going to also export inside of here our token contract address, our link contract address, and our Oracle address as well, both as environment variables inside of our terminal where we're going to run our truffle program. So we want link address and we want Oracle address here. So I'll just do that heavy lifting real quickly, and then we'll look at how all these pieces kind of interact with each other. So first one will be the link address, which is this guy. Okay. B9B, B9B, and then we want the Oracle address as well. Just for sanity, I did run all of this earlier, and this all worked as expected. Essentially, what this overall program is going to do is it's going to deploy our bespoke Solidity contract. It's called ethprice.solidity, like I just said. And then it's going to ask for a function to be called. It's going to go ask for the Ethereum price to be retrieved, and it's going to pass the job ID as an argument to that call to inform the Chainlink node what to do, and for the Oracle smart contract to be able to proxy back the payload that's returned. Okay. So the last thing we need to do is we need to export our Ethereum URL, our Kaleido RPC endpoint. And we'll do that by just hopping directly into a node. And we'll use the connect door here. We're not going to dive into the REST API gateway very deeply today. That's something that we tend to cover every Wednesday, but this is an absolutely critical feature inside of Kaleido, and really, really worth wrapping your head around, not only in terms of transaction submission, but in terms of consuming events in the opposite direction from the blockchain. We're going to go in kind of the classic Ethereum door here, native JSON RPC, what you would use with Truffle or what you would use with a client library like Web3 JavaScript. Everything in Kaleido, every service endpoint, every node endpoint, every administrative endpoint is protected with boundary security. So if we're accessing a node or we're accessing a service, we need strongly generated credentials in order to have secure TLS authentication to that endpoint. So you as an administrator, as an end user, you are responsible for storing these, for deleting these, for regenerating, for cycling these. Kaleido does not store these on your behalf. We store a hash in order to do that authentication, a salted hash. This is what we're concerned with here, this fully fledged connection URL with the app credentials embedded inline here. So we're going to copy that guy, and then we're going to export this as our final environment variable as ETH URL. And what this is going to do, this is actually going to be used by our truffle configuration, our truffle config JavaScript file here, and using one of those core Web3 APIs, the provider API specifically, this is just going to consume that environment variable. The rest of this program is really, really trivial, with just some nominal amounts for gas and gas price here, and then some definitions on the compiler. What we're more concerned with is actually our test program here. the ETH price JavaScript, and this is what we're ultimately going to try to invoke. So this guy is going to be able to consume those variables that we just exported into our environment. And like I said, it's gonna instantiate our smart contract, and then it's going to call a method inside of that smart contract, passing the job ID so that the Chainlink node can do the work that we're asking it to do. And so that payload can be passed back to the Oracle smart contract and ultimately back to our smart contract in question, ethprice.sol. Okay, so I think I have exported every environment variable that I need. Hopefully I haven't missed a step here. And we should, inside of our terminal, simply be able to run the truffle test command here, looking for behavior that we saw here about an hour ago. So cross our fingers and run truffle test. So everything's already compiled, so it's not going to need to do that heavy lifting anymore. Really, all we want it to do is we want to get to the point where it can call that that JavaScript test program and do those two actions that we just identified, instantiating and then passing along the job ID to return us the Ethereum price, or in our scenario here, more accurately, the Bitcoin price. So we'll be patient, we'll be confident, and we'll let this do its work. So if bearing in mind, there is a lot of behavior that needs to take place here. There are a lot of proxy calls, and there are some, I guess, some compartmentalized or some bifurcated interactions here, specifically with the Chainlink nodes, having all of those communication flows and doing those instructions that we asked it to do. Okay, so this worked as expected. And then, you know, as you're building out your application, you can extend this as much as you want to actually surface the price right here in a log statement, to consume the price inside of your smart contract and drive subsequent logic. But what we'll be able to do is we'll actually be able to go look at the run of that job, right? We have this job ID, and we can go look at different variants of when it was executed and the values that were returned. So inside of our administrative dashboard, we can do a refresh and we'll see a recent job run for this ID here. And if we go ahead and look at our get call right here, we see, you know, the current ticker price for Bitcoin here. So pretty easy to wrap your head around, I would say, sort of interaction with an Oracle. We also do have Rhombus, worth mentioning, which again is going to be more of a collectively curated and a bespoke API that your organization or your consortium collectively develops with the Rhombus team. Chainlink is wonderful because you have the ability to define your own jobs. You can define your own endpoints, and you have, you know, shared oversight, shared purview kind of into those definitions. So I'll pause there and open up the chat. I think I saw a question come in. Okay, a couple questions in the Q&A. Are there GitHub examples for these? Are there any GitHubs for the smart contract examples? Yeah, so this is a public GitHub repository here. Just github.com/kaleido-io. I think we have at least a dozen of you know, public libraries, whether they're, you know, automated frameworks, whether they're drivers, whether they're sort of service examples, or whether they're Web3 client library examples. Two that are really worth looking at. This Chainlink one, obviously very apropos to today, but also our Kaleido JavaScript example, Kaleido-JS, and this will show you how to use Web3 and do a combination of things, actually, even do delegated signing, do external signing, use the node to sign, and do some of the, I wouldn't say complicated, but more involved interactions beyond just deploying a smart contract. Shows you how to, you know, basically invoke the core methods and the core APIs in those libraries there. Okay, so the last thing I wanted to show today, and I'm not going to go ad nauseum into all the features, but I just wanted to show the ability to do some basic cloud integrations when you're creating a node. If you've intended one of these before, or if you've been familiar with Kaleido, you'll know that when you create a node inside of your environment, wherever that node is deployed, if it's in AWS or if it's in Azure, you have the ability to leverage and weave in existing services that are in that cloud and that are under your own control. And there's 4 services that we give you. There's KMS, where you have a master key that's used to encrypt your disk, basically turn it into ciphertext that's only unlockable, decryptable by this master key held in your own KMS service or Azure Key Vault service. Log streaming, this is pretty self-explanatory, but being able to take your Geth, your ETH-Connect, your Quorum logs, stand those up into your own dashboards and have a holistic side-by-side view of your processes, of your application stack and Kaleido. Backups, again, very self-explanatory, I hope, but this gives you extra assurances on redundancy and for business continuity. So you have full confidence that, should Kaleido up and disappear someday, you can actually recreate down to the exact signatures on your existing private permissioned Kaleido blockchain. And then lastly, this is only available on AWS, but private networking. So the ability to use a virtual private cloud, use a private link service, and keep your payloads, keep your packets solely on the AWS cloud backbone. So super cool for highly regulated financial data, PHI, things like that. As a best practice, the less you write to the blockchain, however, is for the best. It's sort of kind of blockchain 101. Once it's written, it's indelible. So keeping PII off the blockchain is typically a best practice. So what I'm going to do is I'm just going to show how to do a KMS integration. And the main thing to take away here basically is using your IAM system, using your Azure Active Directory, wherever your user management is taking place in this cloud provider, you simply need to provide some permissions to one of your users to be able to interact with these services, whether it's the KMS, whether it's being able to write logs or create log groups, or whether it's being able to write payloads to a blob storage or a S3 bucket. So we'll do KMS, but this is recyclable onto any of those other configurations, whether it's log streaming, whether it's backups, or whether it's even the private networking. So inside of the AWS portal is where we are now, and we're going to go to the identity and access management. So we'll just do this from step 1. So what I have is I have a user resource group, and I have a single user inside of here. And my username is my name with the 2 after it. What we're first concerned with is we're going to need some security credentials. We're going to need a user ID and an API secret in order to authenticate into the cloud provider and make sure that this user actually has the permissions that they're going to need to do a decryption of a key, or to write to a bucket, or to stream logs into a logging group. And so I have an existing access key and ID. What I'll do is I'll just create a new one. Similar to how we do app credentials as a best practice, these are ephemeral. So you as an administrator, and I'm sure most everyone is comfortable, on these admin dashboards and with Azure, with AWS, with GCP, with the cloud of your choice. But you are responsible for this key management. So follow best practices. Maybe don't put these on a notepad on a live demo, but this is what I'll do for this example, and I'll delete these right after. So we'll copy these 2 things, and these are parameters, these are arguments that we're going to need when we make this configuration here on Kaleido. Okay, so we have those 2 guys, and now what we want to do is we want to apply permissions to this user, to Nick Gasky #2, or whatever the username is in your scenario here on AWS, on Azure. You're going to want to provide those permissions to KMS or to Azure Key Vault. So what we'll do is we'll go ahead and create a master encryption key that will be used to encrypt that node. So I have a couple here that I was experimenting with. We'll go ahead and create a new one. This can be a symmetric key. We're not doing, ECDSA, and we're not doing sign verify logic here, right? This is literally a one-way encryption key that we just need to, use to lock and then use to unlock and hold those key materials on the node in memory only. They'll never be persisted to disk in plain text if you use this configuration technique. So I'll go with symmetric. We need an alias for it. Call it Kaleido. I already used 1, 2, 3, so we'll say 4, 5, 6. You can obviously upload, your own identifiers, your own rhetoric, and your own tags. I'll skip that for the time being. And then the important piece here is we need to either define an administrator. So I'm going to make my user the admin for both of these operations. And then we need to give one of the users permissions to be able to access this key. So I'll make my guy both, right? I'll give him full permissions and I'll make him the administrator as well. Okay, so here's the policy and then we can finish. One important thing to bear in mind, and this can get a little tricky on Azure, especially on AWS, is kind of this cross region. So a lot of these services will, for example, when you're in the user and you're in the IAM service, those tend to start you off in US East and Columbus. When you hop into the key management service or the buckets or the log streams, those can change your regions. And Kaleido needs to know where this utility, where this service exists, whether it's a log streaming group, whether it's a bucket, or whether it's a key here in our scenario. And you can tell what region you're in with this notifier here, or even in the URL, US East-1. So we'll click finish, and now we've actually created this key and we've applied permissions, we've applied authentication to one of our users, my name, Nick Gasky, number 2. So the last thing on Kaleido is we just need to supply some of that information. So this is a name for the object on Kaleido, the configuration object. So this can be anything you want it to be. Kaleido example key config, right? Just a string. And now we need to tell Kaleido where that key exists. And that's why I pointed out the fact that we were in the Virginia server and not in the Columbus, Ohio US East number 2 server. These are going to be the username and the secret for our user. Those 2 things that I pasted on the clipboard. And then this is going to be the alias for the key, the name that we applied to it. We were Kaleido 456. So the last 2 things I need to do are just supply those secrets right there. And this will create a configuration object that we can then bind to our node. So we'll paste these 2 strings right here. And I'll delete these right after the demo. And this will, oh, don't log me out. Okay, well, I was too slow, so we'll need to try this one more time. So as I was sort of meandering through all of the nuances of AWS, got logged out of Kaleido. However, US East-1, Kaleido 456, and then those final strings that we had there, the secret and the username. And again, this should, if I've done this properly, this should create the object, and then we can take that configuration object, the definition of what we just created, and we can bind that to our node, right? And so now when we create this node, it's going to go through those operations of actually calling out to the key management service to encrypt the file system. And then when the node calls up again, it's going to call out one more time to decrypt and hold in memory only, basically those critical signing materials, your default Ethereum account and your node key for consensus. So go ahead and click finish, and this will take a few moments for that node to come up. We can do a quick refresh and we'll see that configuration object sitting here in our environment. And then we'll see this node that's wrapped with that configuration object as well. So very easy. That's extensible, like I said, to log streamings, to backups, and then if you're interested in sort of the private link service, the private traffic, that involves a few different variants of configuration that some Kaleido administrators can help with. So definitely something that happy to talk about offline. And inside of our docs, we have sort of ad nauseum documentation walking you through how to do all these steps, walking you through how to even create those objects and those resources inside of AWS. So this guy is still initializing here. But essentially when this container starts, and it started, I'll go ahead and rename it node number 4. And we have a fully integrated Kaleido node now with KMS. So very, very easy to do. Again, I did all of that inside of the console, but you know, as I mentioned, everything is automatable and everything is accomplishable through our API, creating that configuration object and then creating a node and passing in that configuration object when you create it, when you stand it up. So I'm gonna stop there for today. We have some really, really exciting, awesome stuff that is about to be released on Kaleido. It's going to make for some very, very interesting, refreshing demos with a new look, a new feel, and a whole lot of additional extended functionality on the platform. So I want to save everyone a handful of minutes on their Tuesday, and hopefully you can you know, extend those back to Kaleido next Tuesday and onward. As we really, really explore kind of a changing ecosystem in Kaleido and the addition of some really, really exciting new services and new technology and functionality. So there's a few questions in the chat. I'm just going to open these up. Yeah, so one of the questions was, do we have a UK or EU region? I'm also going to paste my email inside of the chat, so anyone can feel free to take any questions offline with me. Some of these are a little more advanced. But yes, the question was, do we have a UK or an EU region? Yeah, we have AWS Frankfurt in the EU. So very easy to, you know, start your consortium in Europe, and then as it decentralizes, you know, bring on additional clouds or additional regions around the world. Another question was around the cost to run the services. These services, these integrations and configs on Kaleido are free. You're going to bear the cost for, you know, your storage on S3 or on a blob container. You're going to bear the cost for, you know, KMS or Azure Key Vault or the log streaming. The one thing that Kaleido enforces is you need to be on a business or on an enterprise plan in order to run these services. So all of them are available with the exception of KMS on our business plan. If you do want KMS, that's a feature that's available on the enterprise plan, and it's a very it very much is an enterprise feature, I guess I would say. It's a high additional level of encryption, of security on top of what Kaleido already gives you out of the box. So a few more questions in the chat. Yeah, so I think one question was, if you keep PII off-chain, what info would you exchange in healthcare? There's a way to keep the vast majority of PII off-chain. I guess I would say what you ideally would love to do is you would love to use a hash or some sort of obfuscated identifier on the blockchain, along with some innocuous metadata. So some very, very, you know, meaningful and meaningless PII, basically perhaps like just a name, for example, but nothing that could be, I guess, interpreted as a breach of privacy or something something that would violate the right to be forgotten. There's a lot of considerations that go into PII, but one example that I'll share, Jorge, with healthcare, if we think about the need to share provider records, obviously you don't want that full FHIR JSON file to be on the blockchain with all of the certifications, all of the addresses, phone numbers, you know, places of practice, etc. What you might want though, and we've done a demo on this, what you might want to do is take a hash of that payload, pass along, an NPI, and pass along perhaps a name for that payload, and then use a service, kind of an ancillary off-chain service, to securely exchange that data if another participant wants to purchase it or requests it, for example. We've shown that with our document store service, with our on-chain registry, and with our event streams, kind of doing this full end-to-end flow of exchanging really, really sensitive data, but keeping the actual on-chain footprint to an absolute minimum. So I'm going to share my email here for folks. And again, happy to take any questions, any conversations offline, whether they're technical or whether they're commercial. The only latency, there's another question, is there latency in the enterprise architecture as the blockchain grows? Not necessarily, right? What you can have is, as new nodes come onto the blockchain, there is a necessity for these nodes to replicate the chain and to catch up. If you're then asking that node to do more work, for example, if you're asking that node to constantly mine transactions, or you're going for queries, or really, really overburdening HTTP calls, to that node, then you can ultimately end up with something of a suffocated chain. But what we've introduced in Kaleido, with some of these algorithms, IBFT to be precise, we've added the ability for the blockchain itself to grow, for the number of nodes to increase and participants to increase, but to still have an optimized algorithm by allowing the signers to circuitously rotate in and rotate out. It's a really, really nifty feature, and it allows for, we call it equitable participation, I guess, inside of the consensus algorithm. So for IBFT to perform as it's expected, you tend to want to cap the number of signers at 16. Otherwise, you have too many threads, basically too many packets of information being exchanged, and you're just going to suffocate that infrastructure with too much communication. So this is literally just round robin, last in, first out, basically, or first in, first out, whatever the accurate description is. But a very round robin circular flow here. So one of the techniques that we have in Kaleido that allows you, to dynamically continue to expand your environment with more nodes, with more clouds, and with more participants as well. So a few final questions that we have here inside of the chat. Question around identity management. Please share the smart contract of the healthcare example. Yeah, so what we're going to do is we're actually going to curate all of the talks and all the Tech Tuesdays that we've done. So you'll have in a single spot kind of this cohesive collective view of all of these different features and all these different examples. So that'll be available very shortly, mostly. Identity management marketplace. Yeah, so in the very near future, you're going to start seeing a lot of additional extensions to OpenID and IAM integrations as we embark on kind of the next versions of Kaleido. So I'll give you an answer without an answer, Diego, but I'd say stay tuned in the very, very near future. Again, my email is in the chat. Inside of the product, it is free to create a starter plan to go ahead and get going on Kaleido. You can use the Contact Us button if you have a sales inquiry or if you have a technical or product question. This gets routed to our broader engineering team and our support infrastructure. You can also, again, use my email that I pasted in the chat, and we will continue to do these twice a week. On Tuesdays, focusing on technical topics, and on Wednesdays, actually going through the process of creating nodes and creating networks and, instantiating, our first smart contract using that REST API gateway service that we have. No, so the computing power is really minimal. One of the questions in the chat is computing power still an issue that was originally identified with blockchain. So I think we need to, sort of put the two different blockchains into their respective buckets of public blockchains where everyone's allowed to participate, and private blockchains here. when you're in a private blockchain, you are invited, you are authenticated, and you are a known individual. We even take that a step further in Kaleido, allowing you to put X509s and digital certificates underneath your identity so that you can have full KYC, full AML compliance. But at the end of the day, these algorithms are just voting. They're voting rounds and they're digital signatures. They're not trying to discover that's magical, that secret nonce, right? To fulfill the difficulty target of a Bitcoin or of an Ethereum network. And as a result, there's no reward for being the minter of a block. It's essentially all hands on deck and allowing for equitable participation in the consensus algorithm, like we saw with IBFT and that rotating signers orchestration. So no, the bottlenecks that can occur in a private network tend to arise really from the application tier. For example, if you're using a Web3 based approach, you're doing high concurrency and high throughput, and you start running into nonce mismanagement issues, and you ultimately end up with an enormous amount of queued transactions. There's also different scenarios where if you configure one of your algorithms improperly, for example, again, if you use proof of authority and you don't have an odd number of nodes, then if a potential fork arises, there's going to be that split brain scenario where you kind of have two different canonical chains, two different heads, and you're just going to stall. So these are some of the considerations, but Kaleido, as I mentioned at the beginning, we've done our best to kind of remove all of those otherwise complexities that might exist, just standing up the blockchain or at the actual application submission layer. We've tried to take those off of the user here. We'll do this as the last question, Jorge, and then we'll wrap for today. Is one obligated to define an exchange amount for smart contracting, or can the exchange be without monetary value? Yeah, so it's completely arbitrary, right? It's really up to the business network to either enforce, gas prices or gas, for smart contract execution. We give you token utilities for ERC20s and ERC721s. But we also give you that, that Ether pool right out of the box. So every single environment in Kaleido has 1 billion Ether inside of the Genesis block. So you as a business network, you can just use the intrinsic token and you can, allow that to be something fungible. You can allow it to be a utility token and you can use it as an enforcement for, smart contract invocations. You can also weave, other forms of token economics into your use case. So on our demo with the document store, we showed the ability to actually be able to purchase those documents, to be able to send one party a certain amount of tokens, and in return to securely receive that document, the healthcare provider payload, as an example, securely submitted via our document store service. So it's really flexible, and the answer is it depends on your use case, right? So everything is contingent on the business network, on the business logic, and on the objectives of whether we want to charge, whether we want to incentivize for good behavior, et cetera. Cool. Well, thanks for all the great questions today. Oh, looks like someone said they can't see the email in the chat. Let me try that again. I've done this before, and I've only shared it to all panelists. So here we go. Trying one last time. That should be good. So yes, again, feel free to reach out to me with technical, with commercial questions. If you have, specific questions about your company, about your project, if you'd like to hear more about partnership programs, about the packages that we have, everything's on the table. And you're also welcome to create your own Kaleido account. It is free. You can use the Contact Us button inside of the console, again, for sales inquiries or for product assistance. So a lot of different ways to get in contact with us, and we're very accessible on the webinars, on our help desk service. And I should also mention, as we're wrapping up, we are doing a webinar this Thursday with AWS, with Consensus Health, and with some thought leaders in the blockchain and in the healthcare space, focused on COVID, obviously, but it'll be a really fascinating mix of basic different subject matter experts that are going to share their perspective on enterprise blockchain, on healthcare, and on COVID. So I'd encourage everyone to just check out the Kaleido website and go ahead and sign up for that if that's something that you might be interested in. All right, I think that does it with the questions. These will be sent out, the recording along with the deck. And I sincerely thank everyone for attending. I hope everyone is settling into kind of these new social and work life norms. And I very much hope everyone is staying safe and healthy, everyone and their families as well. So thanks again for attending. Tune in next Tuesday. We'll have some very, very different stuff. It'll be really, really exciting. And then every Wednesday, we'll do the high-level 101 walkthroughs. So thanks again, and have yourselves a great Tuesday. Bye.